Okay, with this review, guys, we'll see how long this takes. I kind of am doing a quick overview of just everything we've learned, just to remind you a couple things when you have the quizzes to practice it on your own. This first slide is your last chance to copy down all of the formulas if you need to. This is every single formula we have. Again, for the prisms, when I taught it, I gave you one formula. If you would like to copy down the specific formula for the prisms and pyramids now, you can. But again, just be very careful when you're copying this to make sure you copied it correctly. Here for the cylinder and the cone, this is r squared. For the sphere, it's r cubed to the third, right? So be careful, that is different. This is 4/3 pi r cubed. This is 1/3 pi r squared. That is not a typo, that is correct. And then don't forget that we also have density and population density were our last two formulas there as well. So if you need to pause the video and copy this down so you have it all in one place, you can do that. Maybe you can take a picture on your phone, would be easy too. You have it for the test. Okay, so on to review on naming shapes. Few questions on the test. The first few questions are going to be identifying the shape. So I know we get prisms and pyramids mixed up, but looking at them, hopefully we can see a very clear difference. Notice again, all of the pyramids come to a point like this. The prisms are not like that. The prisms are much more flatter, right? So the difference is a prism again has two bases that are the same. Notice we have these two triangles that are the same. This is all rectangles, but in particular, those two rectangles are the same. These pentagons are the same. These hexagons are the same. And the rest of the sides are rectangles. So again, it's a prism if we see two flat bases like that parallel to each other. A pyramid, again, comes to this point and is named by what it's sitting on. This is sitting on a triangle, so this is a triangular pyramid. This is sitting on a rectangle, so this is a rectangular pyramid. This is sitting on a pentagon, so forth and so on. That's how we name it by its bases. So again, try and get that burned into memory. The difference between prisms and pyramids are very clear to see when you compare them to each other. It's when we're looking at one shape that we're like, wait, is this a pyramid? Is this a prism? Try and make sure you understand the difference. Now, the last three shapes are all circular. Cylinders, cones, and spheres, they all have circular components to them, right? A cylinder has two circular bases. A cone has one circular base, comes to a point. And then a sphere is a ball, right? A 3D circle almost. So we should be able to get those for certain. If you miss naming any of these shapes, wow. These ones I can understand. Prisms and pyramids, we can get them mixed up. But there's no excuse for why you can not name these shapes. You guys should know those shapes. Now, we haven't talked about this in a while, but this was actually in our first lesson was cross sections. So remember, our cross section, we had a little video of the ninja guy who was slicing a shape. What we have to do is visualize, again, that cross section is the 2D shape. So circles, squares, rectangles, triangles, those are two-dimensional shapes, flat, right? That we produce by making this slice. So when we have a cylinder here, and I cut angled, do you guys remember what we call this shape? It's not actually a circle because it's angled, it becomes something else. We call this an ellipse. Again, if you thought oval, it's the same thing. In math, we just call it ellipse and not oval. So if we tilt it, we're kind of elongating it, which causes it to become an ellipse and not a circle. But here, if I have a horizontal slice, again, imagine just cutting parallel to the base. What shape will this be? This will be a circle, and that's because we have a circle base here that I am cutting parallel to. So if I were to turn it and then turn it to face me, it would be a perfect circle because it's cut flat on. Now here again, it helps sometimes if we can kind of follow with our finger and outline the shape we're looking at. If I were to cut a cylinder halfway down and then turn to look at it, what shape is it going to create here? This is a rectangle. If we cut a cylinder and then turn to look at where we cut it, you would actually see a rectangle, straight up and down and straight across. Okay, let's try two more now. We're a different shape. We're talking about a cone here. And again, try and imagine this shape in here. What do we think is going to be right there? This is going to be a circle and not an ellipse. Again, an ellipse is only created by like angled cuts to get that elongated circle. If it's flat like that, it's going to be a circle. Now trying one more, again, there's lots of different possible cross sections we can get. The trick is just being able to visualize. So let's look at this one. What shape do we think is going to be of this cross section cutting down a cone like that? This is going to be a triangle. Again, we can see the cross section in there. That would be a triangle cross section. So you'll try a couple more on your own in the quizzes. Again, there's some memorization you can do. Again, any horizontal slice through a cylinder will cause a circle. Any vertical slice like this through a cylinder will cause a rectangle. However, if we can just visualize it, then we can get the right answer. We don't have to memorize. Now, this was another thing, again, in the very first lesson that we haven't looked at in a while, solids of rotation. So if you recall, this was us rotating over an axis. I have a flat 2D shape, but when I rotate it, I can create a 3D shape. Again, what I had said in the lesson was pretend that you are stuck in Jello. And if we swing out this piece of paper here and carve a shape into the Jello, what shape would we carve? That's what this is talking about. Now, as a hint here, guys, because you're rotating, a rotation is always going to produce shapes that have circle components. That's because we are rotating, right? Again, what ends up happening is those far corners curve as we swing around. So the only solids you can produce here are, what are the three shapes that have circles as a part of them? Cylinders, cones, and spheres. So these are the only possible answers for these questions. We can't produce a prism or a pyramid because those don't have circular components to them. Yeah, a cylinder has a circular base, cone has a circular base, and a sphere, again, it has circles all around. Yeah, it's made of a lot of circles. So looking at this, if I were to take this kind of flat square here, it's basically like a piece of paper, and rotating it around, what shape would this create? Again, try and imagine the shape I am carving in Jello. This is going to be a cylinder. If we rotate this around, and again, that's actually why if you take a rectangle and curve it, hey, look, you created a cylinder. It's not great, but that's basically why as well. This is a cylinder. Now, what about this one, though? Imagine, again, if I were to carve that into Jello, I swung it all around, we only got three options. What do you think this would create? A sphere. If I were to rotate this around, and again, I showed the example in the lesson of the party decorations. If you've ever seen party decorations like that, it's a bunch of tissue paper cut out in like a half circle, and then you open it up and then glue it back to each other. It creates a sphere. If you ever helped your parents decorate for a party or whatever, you may have seen that party decoration before. Okay, volume. So volume, again, was the biggest part of this unit and the hardest part, honestly, because I've just been seeing you guys having a hard time. I think it's picking the right formula and then remembering all the components. Be very careful also on the circular solids, how to deal with R. I mentioned this in the beginning, R squared versus R cubed. If you make a mistake and accidentally do the wrong one, then you're going to get it wrong. Occasionally also, there will be problems where you have more numbers than needed. So you have to understand what numbers you do need versus what you don't. So try in this example here. The step one is to identify the shape. What is this shape? This is a triangular prism. It is not a pyramid. Notice it has two triangles back to back for its bases. That makes it a prism. So we're going to go and we copy our formula for triangular prism. Take a moment to copy it. Triangular prism. Okay, let's go back. we have volume equals 1/2 base of the triangle times height of the triangle times height of the pyramid. Now, I only have 3 numbers. So the nice thing about this is 1, 2, 3. I have 1, 2, 3 things to plug in here. The nice thing is I can just plug those numbers in anywhere and it's actually gonna come out to be the same thing. This is the base of the triangle. This is the height of the triangle. This is the height of the prism. Again, when we say height of a prism, we mean if we were to stand it up onto the triangle bases, that height would be 8 there. So let's go ahead and plug this in though. We have 1/2 base times the height, which again just ends up being 6 times 5 times 8. If I did 8 times 5 times 6, or 6 times 8 times 5, you'll get the same answer. So as long as you know what 3 numbers you need, for a prism at least, the numbers can get jumbled up and you can get the right answer. So we gotta plug this in carefully. You should get 120. So again, the key part there is correctly identifying the shape and then correctly writing down the formula. With the prisms and the pyramids, a lot of times we can jumble up numbers and it ends up working out. Couple more volume questions here. What is this shape to start with? This is a pyramid because it comes to a point like this, but it's also a triangular pyramid because notice the base. What it's sitting on is a triangle. So this is a triangular pyramid. So we look to our notes and we're going to copy down the formula for triangular pyramid. I'm going to give you a moment to do that. Volume equals 1/3 times, I know this is weird, times 1/2 times the base of the triangle times the height of the triangle times the height of the prism, excuse me. Still, it's for Pete's sake. No, I was right, pyramid. Okay, now I know this looks weird, guys, but this is how you would plug it in the calculator. 1/3 times 1/2 times the base of the triangle times the height of the triangle times the height of the pyramid. Now notice I have 1, 2, 3, 4, 5 numbers technically here, and I only need 3. So this is a situation where we have more information than we need. So we do have to be careful here about what our variables stand for. Now, when we're talking about the base of the triangle and the height of the triangle, we are referring to the triangle it sits on. So we have 10, 13.077, kind of a weird number, and 14 and 14. What are the base and the height of this triangle? 10 is the base, and 13.077 is the height. You do not need, if you see any measurements along the slant, if it's slanted, we don't need it. Any slanted measurements we don't want, and that's what this is. This is a slanted measurement here. My base and my height are perpendicular to each other. Notice they kind of cross right there at a right angle. So this is going to be the base of the triangle. This is the height of the triangle. The height of the pyramid is 11. All the way up, that's the height of the pyramid. So go ahead and plug them in. I want you to try plugging in the calculator and then we'll check. We have 1/3 times 1/2. Base of the triangle is 10. The height of the triangle is 13.077. Sheesh. There we go. Times the height of the pyramid, 11. So we have to plug in correctly. 1/3 times 1/2. Oops. Times 10 times 13.077 times 11. We should get a volume of 239.7, we'll say, 745. The triangular pyramids are probably the hardest to keep straight what the numbers are that we need. Again, when we're talking about the base of the triangle and the height of the triangle, base and height always cross like this. Those are the only two numbers you need, is the base and the height of the triangle. This one right here. Okay, let's try one more. What is this shape that we have here? This is a sphere. Copy down the formula for volume of a sphere. Take a moment to do that. Volume equals, this is 4/3 times pi times r cubed. Again, be very careful you copy that correctly. This is r to the third. Now, r is just 6. Remember, it has to be r. If they give you a diameter, you need r instead. Go slowly. Ask yourself, what do I have? What do I need? They gave me r and we need r. So all we got to do is plug in 4/3 times, remember, we are using 3.14 for pi and 6 cubed. Please try this and make sure you can plug into the calculator correctly. Okay, so we should get times 3.14 times 6. Where's my exponent button? To the third. So we should get 904.32. That should be your answer if you plugged it in correctly. If you did not get that, you probably plugged something in wrong. Make sure you are plugging it in correctly. Okay, we're almost done. I know this one has been kind of long here, but we've just got to talk about density last. So with density, be careful about what information is given. Here's our formula. Remember, there are actually 3 possible places you could plug a number in. 1, 2, 3. We tend to always think we see a formula and we go, oh, there's only 2 places to put a number, into mass and into volume. But no, that's not how a formula works. We can plug in over here as well. If we know the density, that's where it goes. It doesn't go anywhere else. Again, that sounds obvious, but sometimes, like I said, we just go, oh, it's mass divided by volume. I will always divide. No. Sometimes, if we have the density, we're going to plug it in here and then it's solved differently. So let's look at these 2 examples. What is the density of nitrogen if 2.4 grams has a volume of 30 cubic centimeters? So again, here's our formula. .4 grams. What is that? This is kind of tricky. Remember that grams is a weight of something, right? How heavy something is grams. So is that density, mass, or volume? This is mass. Grams is of measurement of mass, how heavy something is. And has a volume. Hey, that's volume. So that's where they go. So I'm going, for this case, I am plugging into mass and plugging into volume because the 2 numbers I have are mass and volume. So I have 2.4 over 30, and therefore I am looking for density. Notice it says, what is the density? So that's why it says density equals. We aren't plugging into density because we don't have it. But again, be careful, guys. Mass goes on top. Even if it's the smaller number, this is why you guys have to go slow. So we get a density of 0.08. So remember, density is a measure of how thick something is. Something can be very light and not, or at least not have a lot of mass, but it can have a high density. If I have a rock, a small rock, doesn't weigh a lot, but it is very dense. It's thick and hard, right? So don't get those mixed up. If it says grams or pounds, ounces even, that's a mass, yeah. So 0.08 is a measure of how thick nitrogen is. Let's look at this one now. The density of mercury is 13.6 kilograms per grams per cubic centimeters. So the density of mercury is, this is density. Think about that for our formula. Now, old thermometers, if you guys didn't know this, really old thermometers, like from the 90s and earlier, contained mercury because it expands or shrinks really easily with temperature changes. So that's how the thermometer went up or down. is it reacted to the temperature change and would either cause the mercury to expand or cause the mercury to shrink. So looking at just a basic, when it is at this density, a certain thermometer has a volume. It's a good idea to write these things down so that we don't lose track of them later. We have density, we have volume. What is the mass? So I want you to try this. Here's our formula. I want you to plug in the 13.6 and the 2 where they go. They go into what they represent. So try it. So 13.6 represents density. That's where it goes. I don't know how to make that any more clear, guys. That's not mass. It doesn't say mass. It does say, what is the mass? So mass is going to stay put because we don't know what it is, but we do know the volume. So that's how we should have plugged in here. Notice the difference between the two questions. It's because they were asking us for different things. What is the mass versus what is the density? So be careful. So let's solve this real quick. I'm going to give you a moment to try it. Make sure you can get mass by itself. Well, the way we can think about this is we can cross multiply. If I have a fraction on one side, I can make a fraction on the other side by putting it over 1. Cross multiply. I get the mass because it's mass times 1, so it's just mass, equals 13.6 times 2. So what does this give us? 13.6 times 2, 27.2 is the mass. That's how heavy it is. Okay, we have one more slide because now we need to talk about the last thing, population density. So again, population density is a little weird, but it works the same way. Remember that there are 3 places to plug into. 1, 2, 3, not just 2. We have to read carefully. Now, as a little hint here, because sometimes they don't use the word population density, but population density is how many things live in a square area. So if they say a square mile or a square kilometer or something like that, that is the population density. So let's look at this question. New York City has 27,000 people per square mile. So right here, this hint, people per square mile. This is the population density. Again, if you see that, people per square mile, that's the population density. This is a lot of people. Again, 1 square mile is from 19th Ave to the freeway, and then Bethany to Glendale. That's 1 square mile, 27,000 people. Can you imagine living in just that little area? Now, if New York City has an area of 302 square miles, hey, area. How many people live in New York City total? So I want you to try this again using the population density formula. Population over area. Where are we going to plug in the 27,000 and the 302? Try it. We said 27,000 is the population density. Again, people per square miles, that's population density. We are trying to find the population because it says how many people, that's population, and the area is 302. Now, what's going to end up happening in these questions, guys, in the density problems, you are either going to multiply or divide. What is population density? You can kind of think what makes sense. It would not make sense for me to divide 27,000 by 302 because I get 89 people. 89 people do not live in New York City. A lot more do. So think about what makes sense also. It makes more sense to multiply, which is actually what's going to happen here. When we cross multiply, 27,000 gets multiplied with 302. And that makes sense because that's, let's see, 8,154,000 people. That makes sense. That's a lot of people, and it's New York City. So once more, think about what makes sense. Let's try this last one here, and then we're done with this video. In a forest that has an area of 150, there are 5,000 deer. What do we think this is? Do we think this is the population density or the population? This is the population. There are 5,000 deers. That is how many there are total. Remember, population density is how many live per square area. So if I just looked at one little chunk, how many people would just live in that chunk? So try it again. Population density equals population over area. Notice they say, what is the population density? So try and plug in where these things would go, and let's see what we got. So because they say, what is the population density? That means population density stays put. We don't know what it is. We do know the population is 5,000 deer. The area is 150. 5,000 divided by 150. We get there's 33 deer. We're not going to put it as a decimal because you can't have like a third of a deer. It's a little weird. But it's an estimation. 33 deer. Again, what that means is let me actually finish this off. Per square, what is this, kilometers? Yes. So that means if I just look at one little square of the whole area, about 33 deer would live there. Again, that tells us how crowded it is. So this was a lot. Now we're going to go ahead and try this on our own. I just wanted to really quickly, I know I went kind of fast. And it was still a lot though, so the video I'm sure ended up being more than 20 minutes. Now you're going to do the quizzes and try it all on your own. I just wanted a quick review. Hey, let's review this concept. Hey, let's review this concept. Now you're going to try it on your own.